Hi guys, welcome to the channel Code by Raghav, and in this video we are going to solve the LeetCode question number 189, that is rotate array, and is the company favorite question, and it has been asked by many companies, many interviews. As you can see, it has been asked by many big companies like Amazon, Salesforce, Microsoft, Google, Uber, Goldman Sachs, Bloomberg, Adobe, Oracle, Meta, IBM. So there's a lot of big names right here, and it's a medium type question, but it's a very easy question. If you figured out how to rotate an array and what the term rotate means. So let's see in the in notebook or in Excalibur, and let's see how we can solve this question. Before solving the question, let's read out the statement what this question states. And we have given an integer array nums. Rotate the array to the right by k steps where k is non-negative. Means we have to rotate, means this 7 will comes rotate on this first index. The 1 will be shifted by 1 index, 2 will be shifted by 1 index. So we have to do this shifts by k times. So that's the rotation means. So as you can see, this is our nums array and the k is 3, means we have to do the rotation by 3 times. So explanation here, you can see one step to the right, and we are rotating to the right, means the value before, means the value will come after the next, not previous. So we have to replace the next value to its previous. And so let's see this explanation of the example number 1. Rotate the 1 steps. As you can see, 7 goes ahead of this array and 1 shifted by, and rest elements are shifted by 1. Now 6 comes ahead, then the rest elements shifted by 1, and the last 5, 6, 7, 1, 2, 3, 4. That's our rotated array, that's our output. So we will see the optimal approach, we will not see the brute force, because brute force is very basic, where you will run the, where it's an nested loop solution where you run the outer loop k times, and you will run a inner loop from this I, from backwards to this point, and you will store this element, last element, in some variable, and you just replacing the value to nums of I equal to the nums of I minus 1, means we are just swapping out the values. The 7 come with the 3, so we are doing the rotation step each at a time, means we are rotating every element. So it's not a very good approach, and in the end, after rotating, we are, what we will do, the variable we take, we will replace by the first variable, the nums of 0. So we will replace it by, it's a very easy approach, and we will see how we can do the optimal approach. So it's your task to do the brute force approach. The brute force approach time complexity of k into n and O of 1 space complexity. So it is not good. If our k is very big and n is very big, so it's not a very good approach. Let's try to solve it with a better approach, better and optimal approach. Let's copy this example and let me make it big. So this is our example. What we will do, we will rotate, we will reverse this entire array first. What's the first step? It's a three-step solution. First step is rotate the entire array. Rotate the entire array. So after rotation, what we will get? We will get the output 7, 6, 5, 4, 3, 2, 1. The next step we will do, we will rotate, we will reverse the elements up to the k minus 1. Up to the, so let me do the indexing 0, 1, 2, 3, 4, 5, 6. So we will reverse the k minus 1 index from the starting. Here it is the k minus 1, so we will reverse that. So let me, it will not the rotate, it will be the reverse, reverse, and the next step we will do reverse the k minus 1 elements from start. So if we do the reverse k minus 1 elements from the start, so what we will get, 5, 6, 7, 4, 3, 2. As you can see, we have already got the starting k elements correct. So we have to move the last step. What we have to do, we just have to, after this k elements, from the k elements, that is 3, from the 3th index to the n minus 1 index, we have to reverse that entire array. So this will be the third step, and what we will do, reverse the n minus k elements from start. So that's the total n elements, that's the k elements. So we have to reverse these n minus k elements. After reversing, what we will get, 5, 6, 7. This is from our second step, and 1, 2, 3, 4. That's our the final step. So if you can see the result, it's the same as our output. So that's our solution, and you can see. So if in interview it will possibly, and it will not allow you to use the C++ STL reverse function. So you have to write it your own reverse function. So you have to know how to reverse it. So it's simple. You use the two pointer approach and place I as 0 and j at n minus 1, and you will run loop until I is less than equal to j, and you just swap it out. Swap ij, and you have to write the swap function also. You can't use that swap STL if they don't allow using the STL. So make sure you know how to write the reverse function, and so the swapping will takes, for this n minus 1, it will take the n by 2 swaps, this first step. And the second step will be, we are swapping the first 3 k elements, so k by 2 swaps from the second step. And the last, we are reversing just n minus k elements, so it will take the n minus k by 2 swaps. So the final time complexity will be So it will be equal to O of n. So if you make them equal, so it will be equal to n. And the spice complexity, we are using the in place swapping of the array. So O of 1, we are not using any extra space. So the solution, it is the O of n. Previously the O of n solution, but the brute force approach, the time complexity of k into n. So that's not a very, it's the quadratic time complexity and it's not very good. So let's try to solve it fast, how we can solve it. So, and here one corner case also. If your array is 1, 2, 3 and k you have given 4, means you have to rotate this array 4 times. So what will be the result of the 4 times? In 1, 1, it will be 3, 1, 2. Second, 2, 3, 1. Third, 1, 2, 3. And the last will be 3, 1, 2. As you can see, when we are doing the exactly k times rotation, we are getting the same input. So instead of rotating this many times, we are directly can move directly to this k. So we have to simplify this k value by k equal to k modulo of n. So what we will get, k is 4 and modulo of 3, that is 1. So we have to rotate this array only one time, so we will get the final output, and that's our final output. So we don't have to do this again, iterations again, reversing the array. And if there is k0, there's also a corner case. If it is equal to 0, means we don't have to rotate the array, so we can directly return the array. So let's try to solve it. And what let's calculate the size of the array nums dot size, and k equal to, we have to simplify the k to remove the extra iterations, extra swappings. And now we can write the reverse function. So the first step, reverse the whole array. So we will reverse, that's the STL I am using. Make sure you write your own reverse and swap function. Begin of nums to the end of nums. Now the second step is, we have to reverse the first k minus 1 elements, or first k elements. K minus 1 is for the indexing, you don't get confused. So reverse, begin from the starting of this array to the k plus k elements. And the last and final step, third step, reverse the elements from k to n minus 1. So what will be, reverse begin of nums plus k end of the array. and there's a corner case. If the k equal to 0 means if the size of the, let's say this is 1 2 3 and k is equal to 3. So after simplifying 3 modulo n, that is 3, we will get 0. So means we don't have to do these 3 iterations. So we just simply return the input array return and just we have successfully passed the test sample test cases. Let's try to submit it and let's see. Yes, we have submitted the solution and our solution is accepted. Let's, so that's it for the video. Thank you for watching.